Alright, this video is introducing you to the mole, and these are the learning objectives we're going to do both today and tomorrow. So, investigate the three methods used to measure matter, such as count, mass, and volume. Develop models of the mole that encompass atoms, molecules, and formula units. Explain the relationship between the mole and Avogadro's number. Use Avogadro's number to convert from moles to particles, particles to moles. And use the periodic table to find the molar mass of elements and compounds. So let's talk about measuring matter with a focus on apples. So we can measure our apples in different ways. We can count the number of apples. Right here I have 4 groups of 3, so I have 12 apples. We can give a name to that count. 12 apples is equal to 1 dozen apples. I can take my 1 dozen apples and I can weigh them and find that the mass of these apples are 2 kilograms. And I can figure out how much space my dozen apples takes up, which would be about 0.20 bushels. And what these represent are just different units of measurement that we can utilize depending on what the substance is. So, what I've also been picky about saying that 1 dozen apples per 12 apples, 1 dozen apples per 2.0 kilogram of apples, is these are all called conversion factors. Conversion factors are important because they don't alter the number that you are using, but they do alter the unit that you are calculating. So all of these relate the count, mass, and volume of apples to each other. The conversion factors for count and mass can be used to calculate the mass of 1 apple. So if I want to figure out the mass of 1 apple, I start with 1 apple. Then I go to 1 dozen apples is 1 dozen apples divided by 12 apples. And you notice that both apple is in the numerator and denominator. That means that unit cancels out. And I would be left with with a dozen apples. Now, it's just like with our numbers. If you have 2 divided by 2, that's 1. If you have x divided by x, that's 1. The same applies to our units. So at this point, I'm in dozen apples, and now I'm going to figure out the mass. So I know from a conversion factor that 1 dozen apples is equivalent to 2 kilograms of apples. So I'm going to put my dozen apples in the denominator and have 2 kilogram apples in the numerator. This allows me to cancel out the unit of dozen apples because it's both in the numerator and the denominator, and I'm left with the measurement of kilograms. 0.17 kilograms is the mass of 1 apple. We have the problem of what is the mass of 90 apples if 1 dozen apples has a mass of 2 kilograms. What I'm going to do is I'm going to identify everything I know. I know I have 90 apples. I know that 12 apples is the same as a dozen apples. And I know that 1 dozen apples is the same, or has a weight, of 2.0 kilograms. So, what I'm going to do is something called dimensional analysis. And the trick to dimensional analysis is you're not actually changing the number. You're changing the unit associated with the number using things called conversion factors. This right here and this right here are both different conversion factors that allow us to manipulate the unit that we're looking at. So you want to be able to go from apples to kilograms. So I'm going to start with my apples because that is my given. And I need to cancel out apples in the denominator. Because just like if you had x over x, that goes to 1, 2 over 2, that goes to 1, apples over apples will cancel out the apples to just 1. So I have 90 apples. I know for every 12 apples, I get 1 dozen apples. But I'm not done. I don't want to be in dozen apples. I want to be in kilograms. So I have this conversion factor right here. For every 1 dozen apples, they weigh 2.0 kilograms. Now, I've done this color coding specifically to show you who cancels out. Apples cancel with apples. Dozen apples cancel with dozen apples, and what I'm left with is only the unit of kilograms. So, to put this in your calculator, you multiply both the numerator values and the denominator values, then you divide. So it looks like 90 times 1 times 2 divided by 12 times 1. And you have to do the multiplication first before you divide, so that's the same as 180 over 12 kilograms. And I am going to leave it at the fraction because I don't actually have a calculator on me. So our math of apples leads us to the concept of the mole. So the mole is a fundamental unit in chemistry used to express the amount of a substance. And it does not represent the cute little creature. It represents Avogadro's number of atoms, molecules, ions, or any other elementary entities within the given sample. And 1 mole of any substance contains approximately 6.022 times 10 to the 23rd entities, or substitute whatever subatomic particle you like, which is equivalent to the number of atoms in 12 grams of carbon-12. So in this problem, we have a balloon, and this contains 5.75 moles of helium. We need to figure out how many particles are in the balloon. And our key thing is that we need to know that Avogadro's number is equal to 6.022 times 10 to the 23rd, and that represents how many particles of helium are in 1 mole. So we start with 5.75 moles helium, and we need to go from moles to particles. So the mole must go on the bottom, so our units cancel, and we put Avogadro's number, 6.022 times 10 to the 23rd, on the top. This means that the moles helium and moles helium cancel out, and now we're in the unit of particles. So if you were to put that in your calculator, that would be 5.75 times 6.022 times 10 to the 23rd. And that is equal to 3.46 times 10 to the 24th.